Hi, this is Dinakar Guniguntala. Welcome to the Bluemix Raspberry Pi demo. The goal of this demo is to illustrate how easy it is to work with Internet of Things devices such as a Raspberry Pi using Bluemix. So before getting into the demo itself, a bit about the architecture of the demo. So this is how it looks like. We have on the one end a Node-RED instance running inside of Bluemix, and on the other end we have a Node-RED instance running on top of a Raspberry Pi which is attached to a remote control car. So we'll be sending commands from the Node-RED instance running inside of Bluemix, and that will control the movements of the car. To achieve this, we need a MQTT broker. The MQTT broker itself is running outside of Bluemix due to the fact that Bluemix only allows ports 80 and 443 at this point in time, and MQTT uses port 1883. So currently I'm using a MQTT broker that's running on iot.eclipse.org. So having something like the sandbox broker that's available on iot.eclipse.org is pretty useful, but the only thing to make sure is to not bombard it with lots of traffic. But in this case, we'll be using very little bandwidth because all we are doing is send commands that control the movements of the car, so we should be okay. Okay, so let's look at the Bluemix side of things. I'm currently connected to the stage 1 sandbox of Bluemix. So as you can see, this is the dashboard, and I have a few applications that are already running. To create a new application, you either have to go to this to either add an application, or you can also click on the catalog and you'll be presented with a number of existing boilerplates, runtimes, and other services. So for the purposes of this demo, I'm currently using the Internet of Things, but you could as well use Node-RED. So let's just create a sample application here. So click on Internet of Things, you'll be presented with this screen. Click on Create Application. It'll take a bit and ask you for a name. I'll just give it a test name. I'll say IOTS test 2 and click on create. This should start giving status messages pretty shortly enough. Once the deploy starts, you should be able to see that at the top right corner of the screen. Since I'm connected from my home network, this is a little bit slow. Okay, so here are the status messages that you can see. So we have a new icon for this, the IOTS test 2. Currently it's getting deployed, so it says your app instance is not running. In the meanwhile, I already have an instance that I had created earlier on. So let me just click on that. So this is the IOTS instance that is already running. So this opens up a Node-RED homepage. Node-RED, as you may be aware of, it's a visual tool for the Internet of Things. It provides a flow, what is known as a flow editor. So if you click on this red button, you'll be presented with a screen. I have a couple of flows that are already defined out here. It is fairly simple to create these flows. So you have a set of nodes that are available here, example nodes, and you just need to drag and drop them. For example, this one is an injector node. So if I double click on this, it provides a certain set of options. For example, you could repeat this on an interval basis. So this would inject a message every 1 second into the flow. So I have a number of injector methods out here, as you can see. So this one, it doesn't repeat. It has a topic of control. This one is for forward and injects a forward message that controls the movement of the car. This one is for the car to move reverse, and this one is to just stop the car. So every time I click on this part of the injector, it manually sends a message. But as we saw here, it could also be programmed to repeatedly send messages based on the options that have been chosen. So this second node that you see here, the calculate movement node, it's a functional node. So this is the function node that we have here. So if you can just, as I said earlier, you can drag and drop here, and then put in some commands here. So if you look at the existing one, I have a bunch of commands that has already been programmed. So what I'm doing out here is to determine the actual command that gets sent out as a MQTT message to the Raspberry Pi. So depending on the particular injector node that the message is coming in from, we do a certain set of things. For example, if the message is coming in from control, then we do a cycle of sending out commands every second. So the first time it will send out a forward, then it would send out stop, then reverse, then stop, and so on. So this cycle of forward stop, reverse stop will continuously be sent every time it receives a message. So that is for control. Similarly, if the injector is the forward, then it just sends a forward message to the Raspberry Pi. And similarly for reverse, it'll send a message as the MQTT payload as reverse, and for stop it'll say stop as the payload for the MQTT message. So once it assembles this, the MQTT message, it just returns that. So the payloads here start from the injector and move to the right across the screen. So you have a payload coming in from the injector, goes to the movement node, and here we decide what is the exact command that needs to be sent, create an MQTT message around it, and then forward it to these two particular nodes. So the first one is a MQTT output node, that is this one. So if you click on that, it is currently connected to a iot.eclipse.org MQTT broker, and the topic is empty because the topic is decided by the functional node, as we saw earlier on. So this is just a node that determines where the MQTT message is sent to. And the other node that we see here is a debug node. So this one gets the message and just displays it on the debug tab that you see here. So and this is just to make sure that the messages are being sent out right, and it's fairly easy to help for debugging. Okay, so let me remove the other nodes that I just created. This flow that you see right here on the top is to determine the IP address of the Raspberry Pi. So every time that you power on the Raspberry Pi, it is possible that it can get a different IP address, especially if you are on let's say IBM network. It's very much possible that you're getting different IP addresses. So it becomes difficult to get to know the IP address of the Raspberry Pi without a console attached to it. So just to make sure that we get the right IP address, as I'll show later on, the Raspberry Pi transmits its own IP address, and this particular node that we see here is a input MQTT node that's listening on to the same broker, the iot.eclipse.org port 1883, and the topic that it is listening on is bmdev a/IP address. So this is the IP address of device A. That's the terminology that I'm using. So once it gets the IP address from the Raspberry Pi, that would just forward it to this particular debug node, and we should be able to see a message on the debug tab out here. The way that you can distinguish between the various different debug messages is from this particular, the name of the debug node. So any IP address messages that are coming in from this would be tagged with the name of IP address info, and the movements that we are sending out from here would be tagged with the movement debug name. So it's easy for us to figure out which one is what if you have multiple debug nodes. So this is just a fairly simple editor that we have that helps us put together a pretty complex set of flows in a very easy to do manner. There are a number of other nodes that are out here. We'll use a couple of them, like the IRC on the Raspberry Pi. I'll just talk about that a little bit. But then there are other nodes that you could explore, and it makes it very simple to work with all these different elements. So you just have to drag and drop and do a little bit of programming if required. Okay, so once you've written your flows and you have your have your flows ready, you can just click on the deploy. So that's the one that, as you can see here, it's actually talking to the Bluemix, and it actually gets deployed. You should see the success message as you saw there. So now we have the Bluemix side of things ready. So we are waiting for an IP address from the Raspberry Pi, and we have a bunch of injector nodes that we can use to send commands to the Raspberry Pi. Let us now look at the remote control car and the Raspberry Pi inside of that. This is not exactly a remote control car. It has a few buttons on top, and if you press them, it goes forward and backward and plays music. So if you look at the inside of this car, I have a Raspberry Pi device here, and this one is a Adafruit prototyping plate that has been attached to the Raspberry Pi device, and on top of that, the Adafruit prototyping plate itself is just to bring out all of the GPIO pins on the Raspberry Pi device and make it easier to access the individual pins. That's all it does. And on top of that, I have a small mini breadboard, this one here. This one currently has a L293DNE chip. I don't know if you can see this here. Okay, so the chip there is used to control the motors that are there on board the car. The motor itself is underneath here, is placed inside of that white casing. So I have two GPIO pins which are connecting to the motor from the breadboard and are coming out from the IC. The IC itself, as I said, is used to control the motors. The IC in turn is connected to a couple of the GPIO pins on the Raspberry Pi device. I have here a USB based battery that provides the power to the Raspberry Pi, and this whole thing fits in pretty snugly into the car. So if I switch this on here, when I switch the battery, as you can see, we have a couple of LEDs coming on, and that resets the GPIO pins on the Raspberry Pi, and that's why you saw the motors getting cycled and the car was moving for a bit. So now the Raspberry Pi device is going to come up, and what I have out here is this one is a mini Wi-Fi, USB based Wi-Fi, and that is going to get connected to my home network. You can see the lights blinking on the Wi-Fi, and so that means that it has now come up and it's on. So I think that's pretty much it for the hardware assembly. So now we have the Raspberry Pi device up and running, and it's connected to the motors, and the Wi-Fi should be up, so we should be able to get back get connected wirelessly to this device and be able to control the car. Okay, so I've just powered on the Raspberry Pi car, and I can see that the networking is up. So let me just get connected to it. Since it's on my home network, I already know the IP address, so I'm going to just type it in out here. That's the Raspberry Pi :1880 is where we have the Node-RED running. Okay, so here we have the Node-RED editor that we are already familiar with, that's running on the Raspberry Pi. So as soon as the Raspberry Pi boots up, it starts the Node-RED, which essentially invokes node.js and then starts these two flows that you can see here. So the first one, as I had mentioned earlier on, is to actually get the IP address. So in this particular case, it is my home network, and I already know the IP address that the Raspberry Pi would be getting every time, but that's not always the case. So this particular flow helps us to get the IP address from the Raspberry Pi and then broadcast it so that we have a way to get to the IP address. So let's look at this particular flow. So the first one, as you can see here, is the same old injector node that we saw earlier on. So in this case, this has been programmed to send a message every 10 seconds. So this one here that you see, it's a exec node, same as this one. So this helps in running a command and getting the output from that command. So if you double click here, I'm calling a shell script that is running inside of the Raspberry Pi that gets the IP address. So all this shell script is doing is to run the IP command and grep for the IP address string and then returning that. So the output of that is passed to the function node. So this has three outputs. You can see the information about this particular node that's been mentioned out here. So it essentially has a std out, std error, and the return code. So currently, of course, I'm not looking at the other two nodes, but that's something that I could have used as well. So right now I'm only looking at the std out, and the std out is received as I said, it's the IP address, and that comes as part of the message.payload. So I just stored that in a global context variable called context.selfip. Have a topic called as pmdev a/IP address, and then I bundle these two things together into an MQTT message, which is what gets sent out. Okay, so this particular message gets bundled and sent to these three different nodes. The first one is the familiar MQTT output node. It connects to the same sandbox server that we have on MQTT broker, on iot.eclipse.org, except that the topic that it's sending it on is pmdev a/IP address. The other pretty interesting thing here is that you could also send this message onto a IRC chat channel. So I'm connected currently to irc.freenode.net onto a channel called dtestred, and the other one is a debug one that just outputs the IP address onto the debug tab that you see here. And so as you can see, let me just clear this up. So every 10 seconds you should see a message popping up here there you see. So this is the IP address of the Raspberry Pi, and that's being output here. So I also have a as I said, IRC chat window open here. So as you can see, DynoBM that you see here is the bot, the Node.js IRC client, as it says. So it's a bot that that joins in as soon as you power on the Raspberry Pi, and the Node.js comes up. The flow starts. It gets connected to the IRC channel, and it sends this message to the IRC channel, the IP address, every 10 seconds. As you can see here, you're seeing the IP address show up every 10 seconds. So this makes it pretty easy to get to the IP address. So now that we have the IP address and I'm connected to the Raspberry Pi, I can just stop this flow. I'll say repeat none, okay, and then I do a deploy. So that should stop this flow now. So you should see that um, the bot has quit as well. Okay, so let's look at the other flow that we have here. So this flow is the main one that actually is continuously polling the MQTT broker for messages coming in. So this is waiting on the topic survey res bm/dev a, which is the same as the one that the Bluemix client is sending messages onto. So once we get a message, we then feed it to this functional node, the same one that we saw earlier on. So in this particular functional node, I'm using something called as a WPI module. So this WPI module is nothing but the wiring pi. So wiring pi is a module that sits on top of Node.js and is available for use within Node-RED. Wiring pi is another open source C source code, open source project that aims to expose all of the GPIO pins that are available on the Raspberry Pi, and actually makes it pretty easy to control the pins that are available on the Raspberry Pi. So here I have a bunch of variables that I'm assigning to the specific GPIO pins that I'm using currently. The front and the back are the main pins that we will be using for this demo. So this is connected to the GPIO pin 7 on the Raspberry Pi board. The back is connected to GPIO pin 0. So this is the one that makes the motor turn in a specific way, so that controls the movement of the car. So to use the wiring pi, this is the global context that we have. So we are just initializing a local variable called WPI to the wiring pi context, and then this is the function WPI.setup that is needed to be called to initialize the wiring pi number scheme. The wiring pi pin number scheme is slightly different from the GPIO numbering itself. These numbers that you see, in fact, are actually the WPI pin numbers. And we are also doing a bit of initialization. So we are setting all of these GPIO pins as output pins, and we are writing to these pins and setting them to low. So you could either set them to low or to high using the WPI.low and WPI.high variables that we have. So they are all initialized to low, and then we look at the payload that has come in from the MQTT message. So if the payload says the command forward, we log it onto the console of the Raspberry Pi, and then we set the front pin to high and the back pin to low. So this makes the car move forward, and if the payload says reverse, we do the opposite. So the front is set to low, the back GPIO pin is set to high, and if you get a message of stop, we set all the pins to low. So that's pretty much it. So this is all the logic that is needed to control the GPIO pins on the Raspberry Pi. And as you can see, it makes it really simple. There's no assembly coding or anything like that. It's just a JavaScript editor, and it allows you to control the GPIO pins. It makes it extremely simple. Okay, so I have another node that actually introduces a delay. So you have set up a command that is asking the car to either move forward or backward, or to stop, and this one introduces a bit of a delay for about half a second, and then I make the car to stop. So I'm using the same set of variables. I could have used global variables here, and I mean, I could have referenced this as a global.front, for example, and made it into a global variable. But I mean, I'm just using local ones here for the moment. And I'm setting all of the pins to low to make the card stop. So this ensures that even if the connectivity with the MQTT broker is broken for some particular reason, that the car does not keep either moving forward or backward, and burns out the motor. So you actually turn on the pins to make it move forward or backward, give it a 500 milliseconds delay, and then stop the car. So that's pretty much what this flow is, and this one just captures the output that we got from the MQTT message and captures it onto the debug tab here. Okay, so this is all that we have on the Raspberry Pi side. So we have all of this flow ready and running. The one thing that I would like to mention here is that you also have something called as a RPI minus GPIO nodes. So these are this is another module that's available from the Wiring Pi module itself, or rather the Wiring Pi package. So you could you could directly control the status of specific GPIO pins, but I mean, I think it's much better to program the pins using the WPI module as we saw out here, because it allows you to do talk to multiple pins at the same time rather than dealing with individual pins. But if you want to talk to specific pins, you could do that as well with these particular nodes. Okay, so we don't need that at this point in time. I'll just do a deploy of what we have here. So this is the one that so we are we have the IP address deployed, and we are waiting for the Bluemix to send us commands. Okay, so now that we have both the flows on the Bluemix and on the Raspberry Pi setup and ready, let's test the whole setup. We have the car out here ready, and this is the Bluemix side. So let me just inject a forward message here. Okay, so as you saw, the car moved. So if you just go to the Raspberry Pi side, you can see that. Okay, let me just clear the debug tab here and inject the flow again. So this time let me do a reverse. So you can see that it says that successfully injected message reverse. If you go to the Raspberry Pi, you see that it has received the message, and that's why it was able to translate it into a moment. So okay, so let me just do a couple of more of those. Forward. Let's forward, backward, Okay, so let me now set the control to do a repeated send. Set up the interval for every 1 second. Click on OK and deploy. Okay, so there you see okay, so let me stop that. Okay, so so that's the whole setup. We were able to send commands from the Bluemix. We do see a little bit of delay. The stage 1 Bluemix sandbox, I guess, is running in Dallas, so the message gets sent all the way from Bangalore to Dallas, and I believe the IoT.eclipse.org server is running in the UK, so it needs to send out the message halfway around the world to UK, and from there the Raspberry Pi device gets the device all the way back to Bangalore, and so it takes a little bit of delay. I guess it's about, I mean, it's less than a second, so from the time that you click to the time that you see the movement, there's about half a second of a delay, but it does work pretty fine. And the goal of the demo here was to demonstrate how easy it is to work with embedded devices or Internet of Things devices such as the Raspberry Pi from within Bluemix. Thank you.